Hello, good day to you. Welcome to the Sec3 E-Math topic of arc length, area of sector, and radian measure. For this video lesson, we are going to just focus on arc length and area of sector. Just like the previous chapter on properties of circle, we have to understand the definition of the chord, diameter, and radius. So as you know, the chord is any straight line in the circle passing through two points on the circumference of the circle, and the longest chord in the circle is the diameter. Alright, and diameter, when we have it, it will be the radius. Okay, so radii is the plural of the word radius. Now moving on, in this portion of the chapter, you have to know the definition of three things: the arc, the segment, as well as the sector. Alright, so this part, okay, let me take a look. Yes, segment. Okay, moving up again, the arc. Well, as the name suggests, the arc is a curve, and it has to be the portion, the part of the circumference of a circle. So as you can see, ACQ is the minor arc because it is less than the semicircle, and the major arc is the bigger one, where you can see it is ADQ. ADQ. So it's bigger than the semicircle. Moving on. Now let's look at segment. Well, segment, as you can see, is the area formed by the arc and the chord in the circle. So over here, you have two segments. One is the minor segment, which is smaller than the semicircle, and you have, okay, let me highlight the minor arc, the minor segment, and over here you have the major segment, the area formed by the arc and the chord. Since it's bigger than the semicircle, it is a bigger part of the circle, so it's called a major segment. Okay, so you can read on of the definition, and this is same as what I've explained. Now moving on to sector. As you can see, the segment and the sector are in different shape. They have different shapes. So what is a sector? A sector, normally when I teach students, I'll write sector, where the C, I purposely write it in this shape to show the shape of the sector, just like a piece of pizza, yeah? So the area enclosed by an arc of the circle and two radii gives me the sector. So if the sector again is greater than the semicircle, it's called the major sector over here, bigger than the semicircle, right? So semicircle is bigger than the semicircle. And then if the sector is smaller than the semicircle, it's called the minor arc. So this is the minor sector over here. Okay, so what is the difference between the sector and the segment? Well, the sector is an area within the circle formed by the arc and two radii, whereas the segment is formed by the arc and a chord. So there is the difference. And some of you may be very smart, and smart enough to tell me that when the two radii becomes the longest chord in the circle, which is the diameter, that is when the sector becomes the segment. When you have the two radii, pardon my ugly drawing, becoming the diameter, that is when the sector becomes a semicircle, and that's when the sector and the segment becomes the same. Okay, moving on. Like I've said, today's video lesson focuses on arc length and the area of sector. So now let us take a look on arc length. How to find the length of arc? Well, it depends on how big the sector is based on the angle of this sector. Okay, so, well, we know that in a circle, the total number of degrees is 360 degrees. And since a sector is part of the circle, the arc length formed by the angle over here will tell us how big this sector is and tell us how long this arc length is. So this is a part or a fraction of the circle. So just have to look at the angle, which is the part of 360 degrees. Over here, part of the circle, you have the circumference, and for the area, it is also part of 360 degrees. Fraction of 360 degrees is a fraction of the circle. So over here, we need to remember our primary school formula for circumference, which is 2 pi r, and area of circle is pi r square. Okay, so now let's look at this question. Example 1. Example 1, you have this question from the textbook. Nonetheless, we have everything here. So in the figure, O is the center of the circle with radius 7.5 cm, which is stated in the diagram. The points A and B lie on circumference, yes, also stated. And OBP is a straight line. Wonderful. So we have PA, which is 14 cm. So we have this information. OA is perpendicular to AP. Well, from your previous topic, we know that this fact is true because, just a quick recap, tangent is perpendicular to radius. Yes. And we have to find the angle POA. POA is this angle. So now let us mark this out so that we are very clear that we need to find this angle. So now let's look at part 1. Angle POA can be found using trois quarts because this is a right angled triangle. And then we have the opposite and the adjacent. We use tangent. So tangent angle POA is equals to opposite, which is 14, over adjacent, which is 7.5. So quickly grabbing your calculator, making sure it is in degree mode to find angle POA. Okay, let me try to write more nicely. We press tangent inverse 14 over 7.5, and that will give us, okay, so in the exam and the test, normally we need to round this off to 1 dp as a final answer. So in order to play safe, we give 2 more decimal places. That means I give it to 1, 2, 3 decimal places. And my final answer is 61.8 degrees. Well, don't just copy my answer. Make sure you press in your calculator and make sure you have the same answer as me. Okay, so this is part 1. Now part 2, I need to find the perimeter of the shaded region PBA. So in order to find the perimeter, we have to know the arc AB. Okay, so let me be clear. In order to find the perimeter, now let's break it down. We need to find arc AB. Okay, this is the application of what we have discussed earlier. And then I need to add in the length AP, which I have, which is the 14 cm, and I need to also add in the length PB. Well, PB can be found if I take OP minus OB. I know OB is 7.5, so I need to find OP. Okay, I need to find OP. I can find OP, since this is a right angle triangle, I can find OP by using Pythagoras Theorem. So now let us find OP first. By Pythagoras Theorem, OP, which is the hypotenuse, the longer side, can be found if I take the square root of 14 square plus 7.5 square, and then I know that OP is positive because it's a length. So
calculation, I will square root, finding the value inside. It is 252.25. Since this is not my final answer, I leave it as it is first. Now continuing, I need to find the length of PB. So PB is equals to OP minus OB, which is 7.5. So I am going to take, let me scroll, 252.25. Okay, I'm sure all of you can write nicer than Mrs. Liao, because the screen is very smooth and I always find it very hard to write on the screen, but I'm still trying my best. Okay, so like I said, give 2 more. So intermediate working, I leave my answer to 5SF first. Okay, I am done with this. I know AP, so I don't need to do any working for that. So now I need to find the arc of AB. Okay, let me quickly divide my space and I can find arc AB. So like what we have discussed earlier, in order to find the length of arc AB, since it is part of the circle and the arc is formed by this angle of over here 61.821 out of the entire circle of 360 degrees. I'm gonna multiply by my circumference, a part of the circle of circumference, 2 pi r, which is 7.5. Then we can compute and we are going to get 8.0923, which is 5 SF. And I found my last portion of the perimeter, so I can quickly compute my perimeter, which is the arc. Sorry, 8.0923 plus AP, which is 14, plus PB, 8.3824, everything press into your calculator. Oh, what did I do? Is equals to 30.4747 rounded off to 3SF is 30.5 cm bracket 3SF. Aha. This is example 1. Moving on to, or rather question 1 of example 1. Moving on to the next question. Here we go. We have to find the perimeter of the shaded region. Oh, since like the shaded region comprises of the major arc, major, bigger than semicircle, right? Major arc and the length AB. So in order to find AB, let's read. Oh, AB is given, and this angle AOB is 30 degrees. Well, we know that since any length that shoots out from the center is the radius, so we have an isosceles triangle here. Since we have an isosceles triangle, we can find AOB. We can find AOB. Okay, so angle AOB is equals to 180 minus twice of my 30, which gives me 120 degrees. So this is isosceles triangle. Okay, pause here first. So in order to find any information about the circle, for example, circumference and area of circle, we definitely need to find the radius. We need to know how long is the radius. So in order to find the radius, I need to find either OA or OB because that's the radius. So here we have an isosceles triangle. If I were to drop down a perpendicular line from the center to the length AB, I'm gonna get a perpendicular bisector because this is an isosceles triangle. So with that, I can find the angle over here, which is half of AOB. Okay,
which is half of AOB. Since this is a perpendicular bisector, I need to divide AB by 2. If I divide AB by 2, I can find this part. Okay, so I will take AB divided by 2, which is 15 root 3 over 4. Okay, so in order to find half of AOB, I can make use of cosine because I have to find my hypotenuse. I'm given the apologies, I do not need to find the angle AOB. I just need to use the 30 degrees which is given, and then I'm done. So if this is the angle involved in this right angle triangle, yes, I need to find hypotenuse, and I'm given adjacent. Adjacent is half of this, which is what we have found, 15 root 3 over 4, half over here, half of it only. So I use cosine. 30 degrees is adjacent, which is half of AB, which is 15 root 3 over 4, and over divide by, okay lah, I do this easier for you all to understand, over OA, which is the radius I need to find. So OA. So over here, you can find OA, which is equals to 15 root 3 over 4, divide by cosine 30 degrees. Okay, so OA is equals to, after you calculate, and amazingly, you get an exact answer of 7.5 cm. 7.5 cm. Alright, okay, so here we go. We need to find the perimeter of the shaded region. Since the arc involved is the major arc, I need to find the reflex angle. This big one that forms the major arc. This big angle, reflex angle. So reflex angle AOB is equals to 240 degrees because I take 360 minus away 120, which gives me 120, which gives me 240. So with the angle, now I can find the perimeter of the shaded region. So perimeter is equals to my major arc, 240 over 360 of circumference 2 pi 7.5 plus AB, don't forget your chord AB, which is given by the question, and after pressing everything in my calculator, 44.406, I have, oops, flying number, 44.423SF. Yay. Okay, let's move on to the next question. We have this diagram. A figure shows two sectors, OAB and ODC, with O as a common sector, given that OA is small r and OC is big R, and my angle AOB is m degrees. We have to find the perimeter as well as the area of the shaded region, which is ABCD. Now let's look at part 1, where my small r is 10, my big R is 20, and the angle involved is 45 degrees. So since we know that AD is equals to BC, because it's the big radius minus the small radius, I can quickly write that AD is equals to BC, which is equals to 20 minus 10, that is 10 cm. So now we can, because we need the perimeter, right? So we need to find these two. Now I need to find the arc AB, okay? In order to find the perimeter, I need to find the arc AB, and we know that since my angle involved is 45 degrees out of 360 times my circumference, which is 2 pi, and the small radius is 10. And I know that 45 out of 360 is 1 out of 8. Yes, so we can get over here 1 out of 8. 20 over 8 is actually 5 over 2. 20 over 8 is 5 out of 2 pi. Alright, okay. Then now let me go and find arc AC. I mean CD. Arc CD. Again, it is 45 out of 360, which is 1/8 times 2 pi, and in this case my radius is the bigger one, which is 20. So after cancelling, 40 over 8 is 5 pi. So which means my perimeter for this part 1 is going to be 2.5 pi, which is 5 over 2 pi, plus 5 pi, plus 10 plus 10, because of the two little lengths here. And I am going to press my calculator. I am going to get 43.562 5SF, and rounding off to 3SF, I get 43.6 cm perimeter. Now I look for the area, okay? Let us now look for the area. Let me use this color. Area for part 1. I just need to take the big sector minus the small sector. So it is big sector. Radius, sorry, the angle involved is still 45 out of 36, so it's 1 over 8. Area, remember, is pi r square. Pi r square minus area of the sector with the smaller radius, 1/8 times pi r square, which is equals to, pressing your calculator, you get 117.81, rounding off to 3SF, which is 118 cm square 3SF. Okay, this is part 1. Now let me do part 2. Part 2, bearing the chip in mind, let us look at part 2. Part 2 here. So again, same steps, AD equals to BC. Now I take the longer radius, 8 minus 5, giving me 3. I need to find the smaller arc, or rather the arc with the smaller radius. Arc AB is equals to, angle involved is 120. 120 over 360 times 2 pi r. Let us reduce this, and you can use this fraction constantly. It's 1/3 of the whole circle. So this is 10 pi over 3. Looking for the arc CD, I will use the bigger radius, 1/3 of 2 pi r. Now my r is 8. So I have 16 over 3. So 16 pi over 3 is my bigger arc. So perimeter is equals to 10 pi over 3 plus 16 pi over 3. Not forgetting my two little lengths. 3 plus 3, and I compute 33.227. I'm sure you can get the same answer as me. 3SF. Now to the area. Area, I use my favorite magenta. Area here. Okay, so area, like what we have done, just like part 1, I am looking at a fraction of the circle, the bigger sector, which is of radius 8, minus away part of the circle pi r square, which is of radius 5. Computing, you get 40.841, and I get 40.8 cm squared. Hey, part 2 done. I'm gonna leave part 3 for you to do on your own. Part 3, let me give you the answer. For perimeter is 263 cm and area is 1640 cm squared, all to 3SF. Okay, 3SF. Okay, let's move on. Last two questions of this video lesson. We have this question without any diagram, so we have to read the question carefully and figure out what it is saying. So during an art lesson, students are required to make a shape in the form of a sector of a circle of radius 12 cm. So radius given, very good. Then we have this perimeter is given to be 38 cm. We need to find the area of the paper used in making the shape. So here we have a sector. I'm assuming it is in the shape of the minor sector, but never mind lah. We just assume it is this shape first. So radius must be the same. Center is O, radius 12 cm. So the arc can be found by taking 38 minus 2 times of 12, which is 24. And I am going to get 14. So arc is 14 cm. Here we need to find the angle of this sector. Let us use theta. Let theta be angle of sector. Then we can find the area, right? Okay, in order to find this sector, I can make use of the arc length to find. Since I know theta out of 360 times my circumference, which is 2 pi r, and in this case r is 12, I must get the arc length, which I found earlier, being 14 cm. So here we go. Theta is equals to 14 times 360 over 24 pi, doing cross multiplication. So theta is going to be, after you compute in calculator, you are going to get 210 over pi. Okay, so now my aim is to find the area of the paper used. I have my angle involved. So area of paper used can be found when I take 210 over pi out of 360 degrees times pi r square. So computing this in your calculator, you are going to get how to do cancellation actually. Here you can cancel away this pi and this pi. So basically you have 210 times 144 over 360, cos numerator here, numerator. Okay. So after you compute in your calculator, you should be getting, yes, 84 cm squared. So over here, tip for you. Since you know that this is not going to be your final answer, you can leave this in terms of pi. Alright, leave this in terms of pi, and then afterwards you may find out, oh, you can cancel the pi away, and you can get a very nice integer for your answer. Okay, let me move on to question 5. The very last question of this video lesson. We have a rather interesting question where we have two circles touching each other. So the figure shows two circle discs of radii 11 and 7 touching each other at R. So we have this straight line ARB, because if they touch at R, then and if these 3 points lie on the circle, we have this straight line. So AR is 11 and RB is 7. Okay, so this is a straight line they have to touch, and this is the radius, this is the radius. Okay, let me pause, I need to catch my breath. Some of you may ask, Mrs. Liao, how do you know that this is a straight line? Well, if you understand the concept of tangent, if they only touch at one point, that means there is a tangent here. And if this is a tangent, tangent is perpendicular to radius, tangent being perpendicular to radius, then these two will be 90 degrees. 90 plus 90 is 180. So ARB must be a straight line. Alright? Okay, so let me erase this away because this will block, obstruct me when I explain. So over here, we have to, first part, show that angle PAB is around this value. Okay, so here we have 11 plus 7. Let me use blue, sorry, part 1. So we can start with AB is 11 plus 7 giving me 18 cm. Okay, so in order to find this angle PAB, okay, let me slow down this angle. I'm going to take a look at this right angle triangle. I know that this is 18, this is 90 degrees. If this is 90 degrees, it's basically 11 minus 7, this is 4. So I am going to use this length of 4, 90 degrees right angle triangle. In order to find this angle PAB, I will use cosine. Cosine angle PAB. Why cosine? It is because my adjacent is 4, my hypotenuse is 18. Can you see that? So PAB is equals to cosine inverse of, you can cancel to write 2 over 9. Then you get, what do you get? You are going to get 77.160 rounded off to 3 dB, which is 77.2 degrees 1 dP. Hey, shown! Part 1, shown. Okay, hence I need to find the area of the shaded region. Hence, I need to find the area of the shaded region. Alright, area of the shaded region, as I can see, this is actually a big shape of the trapezium. Can you see the trapezium? Trapezium, parallel lines 11 and 7, and this height of PQ, which is what I need to find using Pythagoras Theorem. Over here, yeah, 90 degrees, I need to find this. Okay, then I need to take away the sector of PAR, take away sector PAR and QBR. So if I know that this is 77.160, I can find this angle using the angle sum of quadrilateral, and I can find. So now let me do the steps. Do I have space below? Yes. Oh, what did I do again? Okay, come, now let's look at part 2. Part 2, here we have to first find the trapezium. Okay, shall we aim to find the area of trapezium? Okay, let's go. By Pythagoras Theorem, in order to find PQ is actually this length of the right angled triangle. So PQ is equals to the square root of the hypotenuse, which is 18 square, minus the shorter side 4 square. And here we have PQ is positive, so I don't need to care about negative value. So this is going to be square root of 308. Moving on, area of trapezium, let me squeeze here, okay? Area of trapezium, and then I have half times sum of parallel lines 11 plus 7 times my perpendicular height, which is this PQ. PQ is square root of 308. This is not my final answer, so I don't bother to work it out. I just leave it in exact form first. 9 square root of 308. Okay, now we have to go and work my sectors. I have to work out my sectors. Okay, Mrs. Snell will use the space here. So we know that the angle PAQ is found. So now let me find angle ABQ, the other one. I take 360 minus the 290 degrees, and I have to minus away my 77.160. You take note that Mrs. Dell always use more decimal places or more SF for working so that I can get accurate answer at the end. So don't always use the 1dp or 3SF. Use the two more. In this case, 3dp more. All right. Okay, so I found the angle of the other sector. Oh yes. Oh yes. So I can find my shaded region. I quickly find area of the shaded region. I take my trapezium. Okay, steady. Minus my two sector, correct? First sector, 77.160 out of 360. Out of 360, sector is part of the circle, right? Pi r square. My big radius is 11. And taking away the other sector, which is of the bigger angle, but smaller radius, 7. And everything you key into your calculator, you have 32.499, which works out to be no space. We still have to put another equal sign here, but by right we shouldn't be doing this. But due to a lack of space, we do that. 3SF. Yay! Oh, done! Okay, so these questions, depending on whether your teacher want to give you for homework, well, your teacher may give you other homework. So this is dependent on what your teacher is giving you. So here, that's the end of this video lesson. Goodbye, have a good day.